In this video, we are going to speak about the atom and its components. So an atom is composed of three elements or three components: protons, electrons, and neutrons. Protons have a positive charge, electrons have a negative charge, and the neutrons don't have a charge at all. The mass of a proton is equal to 1.673 multiplied by 10 to the power of minus 27 kilograms. The mass of an electron is equal to 9.109 multiplied by 10 to the power of minus 31 kilograms. And the mass of a neutron is equal to 1.675 multiplied by 10 to the power of minus 27 kilograms. Now, I'm not giving you those values because I'm asking you to remember them, but it's just to show you that the mass of a proton is almost equal to the mass of a neutron, and that is almost equal to 1840 times the mass of an electron. And because of that, the mass of the atom is and because of that, the protons and the neutrons make the mass of the atom. Now let's draw an atom. So here we have what is called the nucleus, which is composed of protons in blue and neutrons in white. And here we have the electron shells, which contain the electrons in red. So the number of protons plus the number of neutrons is going to be equal to what is called the atomic mass. The symbol of the atomic mass is A. The number of protons itself is called the atomic number. The symbol of the atomic number is Z. So we can say simply that A, the atomic mass, equals Z, which is the atomic number, plus the number of neutrons. We can use this formula to find the number of neutrons if we are given the atomic mass and the atomic number. We can represent any element like this. If we say that X is any element, then we are going to write at the upper left corner the atomic mass A, and in the lower left corner Z, which is the atomic number. Now let's look at some examples. Let's say we are asked to find the number of protons, electrons, and neutrons for the following elements. For example, tritium, which is edge that has an atomic mass of 3 and an atomic number of 1. So the number of protons is going to be 1 because the number of protons is going to be 1 because the atomic number is 1, and the number of electrons is also going to be 1 because this atom has no charge, and if we have no charge, then the number of protons is going to be equal to the number of electrons. For the number of neutrons, we are going to apply this formula here, which is A, the atomic mass, which is 3 in this case, equals the atomic number, which is 1, plus the number of neutrons. I'm just going to write it as N. So if we just move the 1 to the other side, we're going to have 3 minus 1 equals N. So N equals 2. So the number of neutrons is 2. Let me just delete this. Okay. Now let's try another example, and that is going to be the cobalt, which has an atomic mass of 60 and an atomic number of 27. So the number of protons is going to be 27 because the atomic number is 27. And the number of electrons is going to be 27 as well because we have no charge here. And again, if we have no charge, then the number of protons is going to be equal to the number of electrons. For the number of neutrons, we are going to apply this formula one more time. So A, the atomic mass, which is equal to 60, is gonna be equal to 27, the atomic number, plus N. So N is going to be equal to 60 minus 27. N is gonna be equal to 33. So the number of neutrons is 33. Now another example is tellurium, which is Te 2 minus, and it has an atomic mass of 127 and an atomic number of 52. So the number of protons is going to be equal to 52 because the atomic number is 52. And the number of electrons is going to be more than the number of protons by 2 because we have a 2 minus sign here. If you are wondering how we can calculate the number of electrons, then we can just simply say that the number of protons, which is 52, plus the number of electrons, let's say x, is equal to minus 2 because we have a minus 2 sign here. So that is gonna be x equals minus 2 minus 52, and that equals minus 54. And that's why we have 54 electrons. Okay. For the number of neutrons, we're gonna say that the atomic mass 127 equals the atomic number, which is 52, plus N, the number of neutrons, then N equals 127 minus 52, and that is going to be equal to 75 neutrons. One last example is going to be the calcium 2 plus, which has an atomic mass of 40 and an atomic number of 20. So the number of protons is going to be 20 because again the atomic number is 20. For the number of electrons, it's gonna be less than the number of protons by 2. So we are going to have 18 because 20, which is the number of protons, plus x, which is the number of electrons, is going to be equal to plus 2. So if we solve this equation, we are going to have x equals plus 2 minus 20, and that is going to give us minus 18, and that is why we have 18 here. So we have 18 electrons. For the number of neutrons, we are going to apply the formula one more time. So A, which is the atomic mass, which is 40, equals the atomic number, which is 20, plus the number of neutrons. The number of neutrons equals 40 minus 20, and that is going to be equal to 20. So we simply have 20 neutrons. And that is gonna be it for this video.